1.5 notes, we're going to be talking about combinations of functions. So we're going to be adding, subtracting, multiplying, and dividing two different functions together. So we're going to start by adding them. So we're just going to take our two functions. It says f plus g of x. It can be written like this, or as we see in the sum up here, it could be written as f plus g or f of g of x plus g of x. These mean the same thing. It's just asking you to add both of the functions together. So we're going to take f of x and g of x and add them. So we have 2x plus 1 plus, because it tells us to find the sum, we're adding them, x squared plus 2x minus 1. From here, we want to combine like terms and simplify. So we're going to start with our x squared. Then we're going to add our x's together. So 2x plus 2x would be 4x. And 1 minus 1 would cancel. So f plus g of x is x squared plus 4x. So this would be our answer. Then it says to evaluate when x is equal to 2, so we're going to plug that into our x's. So we have 2 squared plus 4 times 2. 2 squared would be 4, plus 8 would be 12. So sometimes it's going to be written as f plus g of 2 when it asks you to plug in a certain number into your new function. So here it asks us to plug in 2. So it could be written as then evaluate, like how it is in the question, or it could ask you for what's f plus g of 2. These are the same thing, so they're asking for the same. It's just asking you to plug in 2 and give us the answer. We're going to go to example 2 on the left. Here it says find the difference. It asks us for f minus g of x. It could also be written as f of x minus g of x. These mean the same thing. So they're asking for the same thing. So we're going to subtract. F comes first, so we're going to take our f of x function, so 2x plus 1, and subtract our g of x. We have to be careful here. We're subtracting the entire function, so all three terms. So we're subtracting x squared plus 2x minus 1. Now when you're subtracting, you can't just combine the like terms right away. Here we have to distribute the negative to everything on the inside. So negative x squared minus 2x and then plus 1. Now we can combine our like terms. So I'm going to start with my x squared. We'll put it in standard form. So negative x squared. 2x minus 2x would just be 0. Those cancel. And then 1 plus 1 would be 2. So f minus g of x is negative x squared plus 2. Now it says evaluate when x is equal to 2. So we're going to plug 2 in. It could also be written as find f minus g of 2, where it wants you to plug 2 into the x. So that's what we're going to do. We have f minus g of 2 equals, we plug in 2 into our x here, so negative 2 squared plus 2. We have to be careful here that negative is on the outside. It's not attached to the 2, so it's not being squared. So just the 2 is being squared here. So 2 squared would be 4, but we have a negative on the outside, so it's negative 4. And negative 4 plus 2 would be negative 2. So f minus g of 2 is negative 2. Another way that you could find the difference when x is equal to 2 is you could plug 2 in here and plug 2 in here and then just subtract the two answers. So you'd find an answer for f of 2 and then subtract it from g of 2. So it's just a different way of doing the same thing. If it asks you for f minus g of x, it's almost easier to find your function, then plug it in. It'd be more work to plug it into 3 places and then subtract. So it just depends on what it's asking you for. in example 3, we're finding the product. So it says f times g of x. So it could be written as f of x times g of x, which it may have a little multiplication symbol between the two. So we're going to multiply our two functions together. So here we have x squared times x minus 3. We want to simplify, so we're going to distribute the x squared. So x squared times x would be x to the third power, and x squared times negative 3 would be negative 3x squared. So this is f times g of x. Next it says evaluate the product when x is equal to 4. So we're going to find f times g of 4. So we're going to plug 4 into the x's here. So we have 4 to the third power minus 3 times 4 squared. 4 to the third power would be 4 times 4 times 4. So that's 16 times 4, which is 64. Minus 4 to the third, 4 squared here is 16. 16 times 3 would be 48. 64 minus 48 would be 16. So f times g of 4 is 16. So another way we could have solved that, we could have found f times g of 4 is by plugging in 4 into f and g and then multiplying it together. So f of 4 would be 4 squared, which is 16, and g of 4 would be 4 minus 3, which is 1, and then when we multiply these two together, 16 times 1 would be 16. So two ways of doing the same thing. Either way works. Sometimes one way is going to be easier than the other, but not all the time. So whichever way you're comfortable with plugging it in, you could do it before you multiply or after. It does not matter. We're going to save example 4 for Monday. So I'll highlight here. We're going to save the domain for Monday, so I'll do example 4 on Monday also. Next thing we're going to talk about is compositions of functions. So before, those were combinations where we just add, subtract, or multiply. We're combining two functions together. Here's a composition of functions. So we're going to make up a function from two other functions. So we're going to we're still combining it, but in a different way here. So our composition functions, it can be written either way. A lot of people will say that this is FOG, f of g of x, which is the same thing as f of g of x here. So it can be written in two different ways. These are asking for the same thing. So we're going to take the function on the inside and we plug it into the function on the outside. So same thing here. Since g is on the inside, we're going to take g of x and plug it into f of x. So we take the one on the inside, plug it into the one on the outside. Let's look at example 5 on the right here. So here it asks us for f of g of x. So we're going to take g of x, since that's on the inside, and plug it into f in the other. So we're going to take g of x and plug it into the x in f of x. I think it's super helpful to circle exactly what I did here. Circle and draw arrows of what you're putting into where. That way you don't get confused. So here we have the square root of x minus 1. We don't have to do any math here to simplify. We can't simplify from here. So f of g of x would just be the square root of x minus 1. From here, we want to find f of g of 2. So we're going to plug that in. So f of g of 2. Once we found f of g, we can just plug it into the x there. So we have the square root of 2 minus 1, which would be the square root of 1, which is 1. Next, it asks us for f of g of 0. if we plugged in 0 here, we have 0 minus 1, which is the square root of negative 1. We can't have imaginary numbers here. So we know that the square root of negative 1 is imaginary. So this is not possible. It's kind of why that question says, if possible. So this one we wouldn't say no solution. It's just not part of our domain, which we'll talk about on Monday when we go over domain. So it gave us kind of a helpful hint as x has to be greater than 1. Well, 0 is not greater than 1. So 0 is not part of our domain. Can't plug it in here. So this, we have no answer. It's the only thing we could find for this question is f of 2. So this we can say not possible. All right, for number 6, we're going to find the compositions of functions here. So it's asking for f of g and g of f. So these are asking for two different things. So let's start with f of g. We're going to take the inside and plug it inside the outside function. So we're going to take g of x, because that's written on the inside, and we're going to plug it into the x in f. So 4 minus x squared plus 2. If it helps, you can plug it into parentheses here, but here we're just adding, so I would say if it's being multiplied to something, make sure you plug it into parentheses, or plug it in with parentheses. From here, we want to combine our like terms. So we have negative x squared plus 6. The second part of this question says evaluate when x is equal to 0. So we just plug that in. So we could say f of g of 0 would be 0 squared, negative 0 squared plus 6, which is just 6. And then also evaluate when x is 1. So f of g of 1 of negative 1 squared plus 6. Be careful here. The negative is on the outside. It's not attached to the 1. So 1 squared would be 1, but the negative is on the outside, so negative 1 plus 6 would be 5. So f of g of 1 here would be 5. Now we're going to do the same thing, but opposite. So we're going to start with the inside and plug it into the other function. So f of x is on the inside. So we're taking f of x, and we're going to plug it into the x in our g. So here we have 4 minus, now I'm plugging it into something squared, so I want to plug it into parentheses, x plus 2 squared. From here we want to simplify. So x plus 2 squared, we're going to write it twice and FOIL it out. So we have 4 minus, I'll keep this in parentheses since we're subtracting the whole thing. So this would be x squared plus 2x plus 2x plus 4. So we just FOILed that. Then we can combine like terms. So 4 minus x squared plus 4x plus 4. We want to distribute the negative. So 4 minus x squared minus 4x minus 4. And then let's put it into standard form. So negative x squared minus 4x. We have 4 minus 4, which ends up canceling out. 4 minus 4 is 0. So g of f of x is negative x squared minus 4x. Now it also asks us to find f of 0 and g of f of 0. Sorry. So g of f of 0. So we're going to plug 0 into that. So negative 0 squared minus 4 times 0 would be 0. And then g of f of 1 would be negative 1 squared minus 4 times 1. Negative 1 squared. Careful here, the negative is not being squared, just the 1 is. So that would be negative 1 minus 4, which is negative 5. Example 7 talks about domain, which we're going to save for Monday. So we're going to do 7 together. And then let's look at 8. So we want to find f of g of x. So we're going to start with the inside. So we're going to take g of x and plug it into the x in f. So here we have 2 times, so since we're multiplying, I'm going to plug it into parentheses, 1/2 times x minus 3 plus 3. So we can simplify. We can distribute here if you wanted to, and then distribute the 2. But we know that 2 times 1/2 is just 1. So this is x minus 3 plus 3. We can get rid of the parentheses now because we're not multiplying anything to it. So x minus 3 plus 3, the minus 3 and the plus 3 is just 0. So this is just x. So f of g of x is x. Now let's do the same thing for g of f of x. So we're going to start with the inside, which is f. So we're going to take our function f and plug it into the x in g. So this would be 1/2 times 2x plus 3 minus 3. So 3 minus 3 would just be 0. That cancels. So we have 1/2 times 2x. 1/2 times 2 is just 1. So this would just be x. So g of f of x is x. It's not always going to be the case where they equal the same thing. Here, this is just an example. A case in which f of g is equal to g of f. So this is just sometimes could happen where you both get the same thing for both. As we saw in the last example, example 6, we got different things. F of g was different than g of f, which was here. So it's not always the case that you'll get the same thing for composition functions. So these are the notes for 1.5. We'll call this part 1. They're going to be due at the end of class on Friday, so make sure you complete the notes for everything that we did in the video and turn in the notes by Friday. We'll do example 7 and the other example we skipped on the last page in class together on Monday. The homework's going to be due on Tuesday. So if you guys have time in class, start working on the homework. That way you don't save it all for Monday night. It's kind of long because it's meant to be for multiple days. So start working on the homework. Any question that involves domain, just save it for Monday night, but the rest of the homework you guys can definitely do.